proceed to the chapter 2 with the subtopic Assembler Directive. In order to write an assembly language program, it is necessary to use Assembler Directive. These are not instructions which HCS12 executes, but are directives to the assembler program about such things as where to put code and data into memory. Remember, assembler directive are not inside the appendix A. Appendix A is the instructions from HCS12, but assembler directive are not in that instruction set. So the function of assembler directive such as where to put code and data into memory. So we have examples of assembler directive. First, we have EQU or equivalent. Give a value to a symbol. For example, we have len EQU 100. That means we want to use in our program. Next, our program, we don't want to use 100, but we represent len as 100. For example, so actually len equal to 100 means when we want to do in our program. So let's say we have a program add A with len, means we want to add A with 100. Okay, so whatever in A we will plus with 100. So we don't want to use 100 in our program. We just use len. And then we will always use origin, org. The function is to set starting value of location counter where code or data will go. So it means when we start our program, we have to put origin. So if our origin is 800, mean our code or data will be started in memory 800. And this is rarely used, but you may know we have example here. How do we use this section? But I'm not used in this course. But you may know. We just start with this origin 900, for example here. And then we have dc.size and we have the ds.size. Okay, so now we proceed to the example of directive assembler. So we start with origin 900 and then we have label. This is just a label. You can put anything. So let's say we have the data dc.b and then we have ds.b and another one we have dc.w. First, you have to know what is dc.b and what is ds.b. Or in this table, we use ds or dc.size. We have three type of size. One is b, represent byte. W represent 2 byte or word. And L is long word, represent 4 bytes. Same with ds. Okay. So I have put the summary here. Look at the summary. Okay, here. So dc.b, the size is 8-bit or 1 byte. Here. So it just needs space, 1 space of memory. While dot word, it needs 2 space of memory, means 16-bit or 2 byte. And the last one is dc.longword. We have 32-bit or 4 space of memory. Okay, we go back to our example. Okay, so we have DC means defined constant, means that is the data. So when we start with origin 900, so the table 1 is represent an address of 900. So we start with 900 because of the instruction is DC. DC is defined constant, that is the data. And then look at here, we have dot B means one space of memory. And then we have the data. How many data we have? 1, 2, 3, 4, 5. We have 5 data in the size of 8 bit. So all the data is are 8 bit or 1 byte of a memory. So we just put the data 23, and then next 17, and then next F2, A3, and 56. So this represent DC dot byte, the first instruction. I'm sorry, not instruction, HCS12 instruction, but assembler directive. And then next we have DS dot byte. So DS is defined storage. So if we use the defined storage, mean we want to reserve the memory space to be used for the future instructions. So let's say we have byte here. Byte is only one space of memory, one space, but 5 times. So we have 1 byte, 2 byte, 3 byte, 4 byte, and 5 byte. So this one is defined storage dot byte, the second one. And the last one we have DC dot word. So the size is word. And then look at here, we have 43AF. 43AF is 16 bit. So just put 43AF. The data is complete for the 16 bit data. Okay, look at another example. Okay, so let's say this data is looks like same, but we have defined constant word, but the data is only 43 and AF. How do you write the program? How do you write the data into the memory? So we have here DC dot word for 3. So because the size is only 8 bit here, so we need another 8 bit to make it a 16 bit. So you need to put 0043, and another one AF 00AF. And then dot long word, we need 4 space of memory. This one is 1 space, so we need another 3 space. So we put 00043, 043, and this one 0000AF.